Good evening, ladies and gentlemen. Welcome to Reference Point. I'm your host, Dave Cokerhook. And with me this evening is Professor Richard Lindzen. Professor Lindzen was for 30 years the Alfred P. Sloan Professor of Meteorology at Massachusetts Institute of Technology. And his biography also tells us that he is an atmospheric physicist. So Professor Lindzen, thank you so much for joining us here at Reference Point. I'm very pleased that you took the time to have a conversation.
Okay, let's go.
So tell me a little bit, first thing I want to, what exactly is atmospheric physics? I mean, that's a terminology, a term with which I am not familiar.
What do you think physics is?
Physics is the study of things, the natural world and how it operates?
It's a little bit too general, but it's things like mechanics, quantum physics, things like this. So in the case of the atmosphere and the oceans, it is the study of how the fluid system works, fluid dynamics, what causes motions, what causes turbulence, what causes heating and cooling, and all of that fits into atmospheric physics.
Okay, and so that has a direct then impact on what we understand as weather and climate, I'm guessing. And so which are two terms that I think are often confused here, at least these days. A lot of people seem to talk about climate when they're talking about weather, or talk about weather when they mean climate. Could you just, for the benefit of the viewers here, really help clarify what those two things mean?
Dave, one thing I've learned over more than 30 years dealing with this topic is when an interviewer asks that question, they're not concerned with the public, they're concerned with themselves. Do you have the faintest idea what the difference between climate and weather is?
I believe my understanding is that weather is the day-to-day things that we experience in our environment: rain, sunshine, snow, heat, cold, whatever. And climate has to do with longer-term, more conditions that are that impact a particular geographic location that can be based on a whole variety of things that I don't understand.
Yeah, I don't think there's any clear distinction. Weather and climate are just different timescales. With weather, there are certain things you can be very clear about. So for instance, if you have a very hot day, that is not from climate. That is from the wind blowing from someplace where it's very hot.
Okay.
If you have a very cold day, it's the opposite. The wind is blowing from someplace it's very cold and bringing you cold air. But, when you get to longer time scales, you have to think a little bit about where these time scales come from. So, for example, if I have a pot of water and I heat it from below and it's cooled above, it starts boiling and you have turbulent motions. And these motions have time scales, sometimes milliseconds, sometimes seconds, very short.
Mm-hmm.
But the atmosphere and the oceans are simply very, very big pots. And the eddies that occur take much longer. So some of them take 5 days to oscillate.
Mm-hmm.
And you tend to see weather changing on timescales of 5 to 10 days. But in the ocean, it's deep and it's dense. Some of these circulations, especially overturning, can take 1,000 years because you have a much bigger and denser system.
Mm-hmm.
And when they take a longer time, they're still part of the internal variability of the system, but you call it climate.
Mm.
And then, of course, you get to very long time scales, millions of years, 100,000 years. 100,000 years, for instance, is the glaciation cycles.
Right. Okay.
They may have external sources. So, for instance, the Serbian astrophysicist Milankovic in 1940 pointed out that the ice age cycles of the last million years or so
Mm-hmm.
have been due to orbital variations of the Earth.
Well,
And
that's interesting. I hadn't heard that.
oh, that's pretty much correct. It's not even, it took a long time for that to be accepted. And it was accepted, then rejected, and so on. But, it's typical. This is a multidisciplinary field par excellence.
Right.
You have geologists, you have oceanographers, you have meteorologists. In 1990, almost no one called themselves a climate scientist.
Right. It was a term that I hadn't heard until the last maybe 20, 30 years.
Yeah, there was a reason for that. No one knew everything you had to know about, in order to understand climate. There were people who understood the atmosphere, the oceans, marine geochemistry, geology.
Mm-hmm.
The combination of all of them was immensely complicated.
That makes a lot of sense to me. These various disciplines, understanding what goes on in the atmosphere, understanding what goes on in the oceans, the geologic activity that's going on. When we look at some of the things that we've tried to do in the last, 20 years or so with computer modeling to try to then have some predictive capability based on computer modeling,
Well,
have we been able to really accurately take into consideration all of those variables?
no, of course not. Of course not. There's no reason to suppose one could. You try, for instance, today's climate scientists, I suspect the vast majority of them could not even tell you which equation is being modeled in these climate models.
Mm-hmm.
The equation is called the Navier-Stokes equation. It is the equation for fluid mechanics. We don't know if a numerical approximation to this works.
Mm.
But we adjust parameters and we adjust things and so on. To actually calculate, you'd have to resolve scales ranging from the size of the planet to millimeters. And even today, that would exceed the capacity of almost any computer, and you would need time resolution to go with it. So you'd have
Right.
a time step every few seconds. We're nowhere near that. And the models, moreover, because they can't do that, have to take all sorts of things they don't know and what they call parameterize them.
Mm.
Parameterize means they assume what they are, or they make up what they are, and so on. And, there are some of them who have freely admitted they know the answer they're supposed to get, so they put that answer in and then adjust everything to make that work.
Yeah, just work it backwards to see if you can come. Yeah. Okay. Well,
but, they have an additional problem. When they go ahead, they always overestimate what you find in the data.
Okay. So why is it, do you think, one of the things that I've observed, and I just, because I read things, there seems to be there's a tremendous amount of angst going on right now. This whole thing about what's going on with the climate crisis, climate emergency, climate this, climate that. We've got all of these things going on, and the protocols here, and the Kyoto thing, and the Paris thing, and all that kind of stuff. It's clear to me that things change on planet Earth, and it have been changing since the planet was created. Okay. And so do we really, the other thing that I believe from my studies of just history is that humanity adapts to whatever is going on in the environment.
Yeah.
So is this something that we there are things that impact. If stuff changes, it has economic and social implications. But how much of a crisis really is there?
There's no evidence of any crisis that is at all unusual. None at all. I mean, you know, I'll give you an example of what occurs. And here you see the conflict between the political actors and the scientists involved in this. And
Okay.
a certain amount of collusion, but here's how it goes. So you have the UN's Intergovernmental Panel on Climate Change.
Right.
And they have three sections. One is called science, one is called impacts, and one is called mitigation. Only one of them deals with science. My experience, and I've dealt with it, and I've been on the IPCC, is, you know, they don't criticize the models much, but they don't try to say anything totally absurd. They try and keep it somewhat straight.
Okay.
And so you have this working group 1 volume. It's over 1,000 pages and no index. So no one can read it. So you have a summary for policymakers. And this tilts it a little bit and tries to emphasize the negative.
Right.
But it's, you know, 20 pages, 30 pages. You can't expect people to read 20, 30 pages.
Not anymore.
So now you have the press release. And out of these 1,000-odd pages, what is the press release? We now feel pretty confident that most of the warming in the last 50 years is due to man's activities. Okay, what is that saying? Well, it's saying we had about a 0.5 degree. Man's activities included lots of things, paving roads and emitting CO2 and so on. And most, well, it's 51%. And since it's a very little warming, it's most consistent with the notion that there's nothing much going on.
Mm-hmm.
So you have this announcement, and then you have the response, and this was, you know, early in the 21st century, of Senators McCain and Lieberman.
Mm-hmm.
What is their response? This is the smoking gun. We must do something.
Right.
In short order, we're under existential threat. Well, now that the politicians said this is existential instead of tiny, what are you going to do? Well, you know, you start having people saying, well, maybe it'll cause sea level to rise and inundate New York and do this. That actually was a product of social science research in the 80s. What sort of thing would most scare people?
Ah.
But you have this funny thing where the scientists say something meaningless. The politicians interpret it as being terrible. They then, and so does the media, and so do the environmental groups.
Mm-hmm.
And so what do the politicians do? They increase funding for science in this
Right.
area.
But they ask for, but they're looking for a particular outcome.
Oh, of course. But the funding, you know, the university administrators love it, and it becomes part of virtue. You're saving the planet.
Right.
Meantime, you're endorsing a narrative that has almost zero chance of being true, that there's an existential threat, that there's a crisis.
Right.
On the other hand, you're proposing policies that involve very real risks of destroying your economy, your energy system, and so on.
Right.
And those are ignored.
You had introduced me to Dr. Kunin's book, Unsettled, and one of the things he talks about in there is that when the scientific community presents the information that it presents, they'll have this sense of there are this continuum of possibility. Okay, and this is almost a very unlikely, somewhat likely, highly likely, but it seems that the media love to they look for the most exaggerated possibilities on one end or the other.
In America, this is complicated. It's even worse in some ways in Europe. In America, it's become a partisan issue.
Oh, yeah. Yeah.
And all notion of probability is dismissed. Remember, you keep hearing it's settled science.
Yeah, yeah, that's the one that gets me, that I've never thought that that could be possible. I mean, take a look at astrophysics. We keep learning things about the universe that we didn't know 10, 15, 20 years ago. How can it be settled?
No, that's definitely, science is a very peculiar word. The opposite of science is the science.
Uh-huh, okay.
And you keep hearing, follow the science, believe the science. And if you question it, you're a denier, like a denier of the Holocaust.
Right.
You don't have public discussions, even though the public is going to face policies that could be devastating. This is unheard of in science, that you don't allow discussion.
So why have we come to this point, do you think? What is it about this subject matter that creates this kind of disparity?
Well, I think early on, already in the 60s, the nascent environmental movement of that time, of course, the old environmentalist Sierra Club and so on existed long before that, but they were looking for something that would give them control over a maximum part of society. And the energy economy is an obvious target. And so already, you had in the 60s global cooling as the existential threat due to the production of energy and the creation of pollutants. And then, the cooling from 1940 to 1970 ended as,
Right.
And so it started warming. They said, okay, what causes warming? Well, that's beautiful. It's CO2,
Mm-hmm.
a minor greenhouse gas. Let's blame it on that, because that's the product of clean burning. After you've every real pollutant, this is what's left, this and water vapor.
Right.
They haven't attacked water vapor yet, but I mean, and so here you have declared it a pollutant. Can you tell me, Dave, let's say we got rid of more than half, a bit more than half of the CO2 concentration we have now, what would happen?
I have no idea.
Did you ever take high school biology?
I did, yeah. Yeah.
Remember photosynthesis?
Right. Yeah. The plants take in CO2 due to this photosynthetic process, and CO and oxygen comes out, and we get to breathe that part.
Yeah. And the plants need the CO2.
That's right.
They need the plants because carnivores, still need meat that ate plants.
Right.
And so you bring CO2 to a bit less than half of what we have now, and advanced life ends. Period.
Isn't there evidence in the records, tree rings and stuff like that, that the concentration of CO2 has been substantially higher when you go back, 1,000 years?
No, millions of years. It was much higher through most of the Earth's history. That's when plants evolved. That's why they desperately need CO2. That's why greenhouse keepers pump in CO2.
Right.
But what other pollutant do you know that if you cut it in half, we die?
Yeah. Yeah, that's one of those unintended consequences, I guess, of a well-intended act.
Well, I don't think we would be able to. But, in the past record, yeah, CO2 has been high, it's been lower, mostly higher. The temperature of the Earth has shown virtually no correlation with CO2,
Right.
except in the cycle of ice ages. There, Al Gore was showing these graphs, temperature and CO2 going together.
Mm-hmm.
There was one problem. The temperature changed before the CO2 changed
Oh, interesting.
by hundreds of years, thousands of years in some cases. And so if CO2 caused it, how come it was lagging?
Yeah. Yeah.
So, there's no evidence in the past that this is a control now. Indeed, given the complexity of the system, the numerous gases, the external influences, the internal turbulence and variability, the whole notion that you can take the temperature of this system
Mm-hmm.
and a single number, and it's controlled by a minor constituent, CO2, and
Mm-hmm.
that's the system. I mean, it's ab initio, it's absurd. But on the other hand, given public ignorance of science, public inability to do arithmetic,
Right.
you have a pretty easy target if you want to promote panic. And we
It,
saw
it,
this with COVID.
it has political what's the word I'm looking for? Yeah, currency. It has political currency.
Well,
And yeah.
you know the name Mencken.
Yes.
He had this wonderful statement, observation, that the urge to serve humanity is, in most cases, a false front for the urge to rule.
Yeah. 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 Um, this has been fun. I'm enjoying this tremendously. We've touched on a lot of the things that you and I had hoped to talk about. I want to ask you just to get some of your thoughts on Dr. Kunin's book, Unsettled. You were the one that told me about that.
Yeah,
I've
sure.
read it. I found it as a layperson easy to read. I mean, it was able to actually grasp the concepts that he was presenting. And I
I
go
think
ahead.
he worked hard on that. I know the history of it, and he mentions it briefly. He felt that the American Physical Society had issued a strong statement on this without studying the matter. So he was asked to conduct a study. He invited several people, 3 on each side, and had a group of physicists listen to it. And, they're not professionals in this, but they realized this was not settled.
Mm-hmm.
What Kunin then did was try and look for where all these claims came from. And he is not presenting, a deep study of it. He's saying, look, here are the UN's reports. Here are the US government reports. Are they even saying what you're hearing on the media, what you're hearing in the political framework? And he's saying, so here's the UN. They say we can find no relation with extreme weather. Here you have the newspaper saying there's an extreme, it's due to climate.
Right.
So if you read any of the literature, even the literature supporting the issue,
Mm-hmm.
you see the foolishness that you see from the politicians.
Right. So how do we deal with this? From your perspective, is a way for us, citizens, to be able to deal with that kind of disparate communication?
How shall I put it? I wish I knew. This has been an extraordinarily frustrating issue because, I know that academia in some ways is very corrupt. It's highly dependent on government funding. Eisenhower warned about this many years ago.
Oh, yeah, right. I remember.
Administrators are making millions of bucks. They are primarily fundraisers.
Mm-hmm.
Virtue signaling is going on. As I say, in the US, it's a partisan environment. And we're only waking up now to the fact that, when I came to MIT or when I entered academia, sure, academia was mostly on the left, mostly Democrat, but it was more like 60-40, 70-30.
Mm-hmm.
Now it's 99.
Mm,
And so academia is highly politicized. And
right.
the political party says this is what we want in order to gain power and influence and so on. You're not going to get much out of academia.
Yeah.
See, the real problem, the way the nation typically dealt with such things, and Kunin makes this point, when we had security threats, when we had military threats, we set up red team, blue team exercises,
Mm,
put people on both sides to try and see, what was going on and debate it and so on.
right.
And that's never been done with this issue. And
Yeah.
it's crucial not because of the existential threat, which is zero.
Hmm.
It's crucial because of the policies. The policies have so much risk involved, so
Right.
much pain involved for the population at large, that we owe it to the citizenry to have this studied and debated. And we're not doing it. Instead, we're telling them all scientists agree it's settled. If you question it, you're a denier.
Right. Right. Yeah. And that is most unfortunate. We have about a minute and 30 seconds left in our show. So the time flies. Absolutely. It's amazing. I found this to be our conversation to be helpful to me, because this topic is something that's been frustrating me for quite some time, because I've had this sense that the extreme claims were not what we were seeing in real life, okay, and that they were exaggerated to the extreme. So having this conversation is, I'm sorry, what was that?
Talking about memory. I mean, remember, this has been going on since 1988.
Right.
All during that period, people have been making predictions. We won't have snow by 2020. We
Right.
won't have. There's not a single one of those things that has ever come true.
That's true. Yeah.
And despite this, you keep regurgitating this stuff.
Why do you think that is?
Because they assume people don't remember from one day to the next.
Yeah, I suppose that's true. Well, Professor Lindzen, this has been a wonderful opportunity, I believe, for us to have this conversation. I want to thank you for taking the time to do this over there in Paris. You're in Paris, France, for a bit of a holiday. So thank you for taking the time.
Not strictly a holiday. Split our year here.
All right, well, good. Well, in the last moment, is there any closing thoughts that you want to convey?
Just remain skeptical and don't worry. The world is not coming to an end.
Fantastic.
Lifetime of your great grandchildren.
All right. Well, thank you very much. And ladies and gentlemen, I appreciate your being there. And don't forget, if you have any questions, you can send them to info@referencepointtv.com and we'll get those questions answered for you. So Professor Lindzen, again, thank you so much for joining us. And ladies and gentlemen, we'll see you next time on Reference Point.
Bye-bye.